Hello, everyone. Here we are again. And once again, we talk about energy. Let's talk about energy because it is a definitely interesting topic. We have already talked about refrigeration units, inverters. I would say that the application of inverters is now a mature application. Less used, but definitely intriguing, is the application of modulating proportional relays. This is, for example, a type of application that we carry out on the central heating control units. When we need to heat a fluid, we have a couple of alternatives. One is to use the classic boiler that produces steam rather than diathermic oil, rather than pressurized water, so overheated water, or use resistors. So our sources of energy can encompass fossil energy sources like diesel, natural gas, or electricity, which can be utilized with burners or electric resistances to heat oil, water, and other substances, among others. When it comes to burners, modulating burners have been in existence for quite some time, and as a result, they are able to modulate fuel consumption based on the thermal load. Regarding electric heating, the situation is somewhat distinct. In practical terms, it involves adjusting the power of the heating resistors. How do we do it? We do it through modulating static SCR relays. In this case, by using a PID temperature control system, which operates with a modulating proportional band control, we can request the resistors to provide the actual power needed at that moment to reach the set point or to maintain the temperature of an industrial process. Energy saving is highly fascinating. Typically, when designing these machines, we often prioritize designing them for maximum power. For instance, if I need to heat a mass inside a pharmaceutical reactor, I need to calculate various factors. These include the time required to heat the mass, the starting temperature, and the target temperature. By considering the heat load, reactor heating requirements, and any losses, I can determine the necessary power to accomplish the task. That's the power of my car. Okay, but when I reach the work point, that's when my product has reached the set point. The required power is no longer the same, it's much less, because in the end, it's a maintenance work. What do I have to do in practice? If my product has leaks or requires an energy input, or the insulation clearly has leaks, I have to provide some energy. Yes, however, it is likely to be only 1/10 of the initial power, 1/3, 1/5. How can I modulate it to achieve the desired effect? In the past, machines with multiple stages, machines with different heating stages, were simply made, and I would modulate the power of the resistors through teleswitches or on-off static relays. So my proportional band thermostat would activate and deactivate, so to speak, the electrical load in order to maintain the temperature. The tri-store, or modulating static relay, enables me to modulate the power and provide the actual power required to maintain the temperature within the proportional band, and as a result, maintain the set point. I get two effects. The first obvious effect is that I save energy, clear. The second effect is that I obtain a very fine temperature adjustment, a significantly more refined temperature adjustment. Then we can play it on the proportional bands, etc. But maybe we'll save this for another video. Here I wanted to focus specifically on energy saving. Many times we have monitored and continue to monitor our plants on industrial plants, and we are well aware of this. The power on which we calculate the machine, which is the power required for startup, for the start of the plant, to bring the process to temperature, is no longer required during operation, because once I have reached the working point, the required power is significantly lower. I believe that the topic is very interesting. Unfortunately, these modulating static relays are now becoming a mature product, so their cost tends to decrease or at least not increase anymore. Thank you for listening. Good day.